if you remember, yesterday we did one example here. In the previous example, we did our previous example where we had taken the requirement in the first example, 40 host using any C class address. When we did this, we got the subnet mask of, what is the subnet mask we got? We got the subnet mask of 255.255.255.192, and the range is 0 to 63 is one network, 64 to 127 is one network. It's a group of 64 addresses. You can see there 128 and 192. 128 to 191 is one network, 192 to 255 is the fourth network. This is the range of addresses where the first address represents your network ID. This is your network ID. And this addresses, the last addresses, represents your broadcast ID. Similar way we did just now we did one example with 12 host requirement. So probably any example, it's the same thing. This is what we did yesterday in the previous class. We did this. Then we got the range 1.0 to this is with /26 subnet mask, nothing but total network bits. So let us try to, many people have a confusion, like suddenly they will ask how they are different networks. So why this is a network ID? Why 63 is not a valid IP address? So let's try to understand how implementation goes and how we need to understand these addresses and how the devices understands actually. So anyway, devices understands all these calculations, but we need to make sure that we have a very good understanding on this addressing. And if you don't have a good understanding on this addressing, then probably it becomes very difficult to design the networks, and also it becomes very difficult to understand how the networks are configured and why we are using these IP addresses in these specific locations and why we are using this subnet mask. So this is something which will give a more clarity on why and how the designing goes and how the devices are given the addresses and how I should understand and how devices understand and how I should understand. So let's take one example. I'm going to take two devices. Assume that there are two computers. They're connected in the LAN, maybe through cross cable or switch, whatever. So, and they are assigned with IP address called 192.168.1.10. The first device have an IP address of 192.168.1.10, and the next device have the IP address of 192.168.1.100. So 10 and 100. And for both the devices, I have used the subnet mask of 255.255.255.0. Okay. So now my question is, do they belong to same networks? And if they are in the same networks, can they communicate with each other? Or in simple, same networks means definitely they will communicate if they are in the same LAN and if the physical connection is perfect. So in general, as per our default subnet mask, you know that by default there are three network portions. This is your network portion, because you know binary ones, these are nothing but your binary ones. Binary ones represent network portion. So this is one network portion, two network portions, and there are three network portions, and the last portion is your host portion. So the same, it's a C class, so probably we are saying that three network portions. As per this, in order to be in the same network, as per our basic IP addressing which we'll learn, if you just keep all subnetting concepts beside, as per our default IP addressing, in order to be in the same network, network portion must be same. So in this example, both the network portions are same. So which means 192 is same, 168 is same, and 1 is same. So probably they are on the same network. So if they're on the same network, if everything is perfect, if the connectivity and all those things is perfect, then simply we say they are on the same networks. They are in the same network. So I'm just giving a simple example without subnetting. So I'm just keeping all our subnetting calculations beside without using any of the subnetting things. Now let's try to understand the same example, similar example, by using a concept of subnetting. So how it varies. Now I'm going to take the same example here, and the example is the same two devices. I'm going to use 192.168.1.10 is the IP address of one device, and the other device is having the IP address of 192.168.1.100. So both the devices are using the same IP address what I used in our example, this example here. So now, but the difference is I'm not using the default subnet mask. I'm going to use the subnet mask of 192.255.255.255.192 is the subnet mask. So now I'm not using the default subnet mask. I'm using the subnet mask which is customized. Customized means once we made some changes, we converted some of the bits. We are not using the default network and the host bits. Now, the same question I'm going to ask, do they belong to same networks? Now, do they belong to same networks or they belong to different networks? So probably can just think out. So now, same network or different network? Okay. So many people, if you're not much clear with subnetting, probably you'll say they are in the same networks, but they are not on the same networks. They are different networks. Now they are on different networks. So now whenever you change the subnet mask, so whenever you write this subnet mask, the device understands. So what the device is going to understand? The device is going to understand that by default there are 8 network bits here. 255 represents. So you can see the table here, which we already discussed in our table. Whenever you have a 255 means there are 8 ones. So which means 255 represents 8 bits, 8 network bits, and 255 represents 8 network bits, nothing but 8 binary ones, and 255 represents 8 network bits. And when I say 192, it is in decimal format. So if I write this in binary, it will be something like this: 1 1 1 2 3 4 5 6. So it will be like 6 zeros and 2 ones. If I take the same example, if I come back to my table, okay, 192 represents 2 network bits and 6 host bits, which means 128 plus, that's what, if I write 2 bits means it's 128 plus 64. It's actually 192. So which means there are 2 network bits. So total becomes how many? So 8 plus 8 plus 8, 24, 24 plus 2. So it becomes 26 network bits. So which means there are 26 network bits. And what about the host bits? The host bits are 6, the remaining 6. So now whenever you write this subnet mask, automatically the device will understand that there are 26 network bits and there are 6 host bits. And whenever you write this subnet mask here, as per our default example, whenever we write this subnet mask, the device will understand that there are 8 network bits, 8 network bits, 8 network bits, and there are 8 host bits. So which means the tally of there are 24 network bits and 8 host bits as per the default subnet mask. So whenever you change the subnet mask, nothing but you are changing the number of bits. So when you are changing the bits, automatically the size changes, because you know the size of the network is always based on the 2 to the power of h value. So in this example, the default subnet mask, the size of the network is 2 to the power of h, 2 to the power of 8, 256 is the size. Okay, so when you have a size of 256, which means the meaning of this is the range starts on 0 and ends on 255. So group of 256 addresses is one network, which means the default range of C class starts from 0 and ends on 255, where 0 will be the network ID and 255 will be the broadcast ID. So 0 is a network ID, 255 is a broadcast ID. So which means anything coming in between 0 to 255 belongs to the same network. Which means if you take our example here, 10 and 100, they are coming within the 0 to 255 as per the default subnet mask. So which means they are on the same network. So anyway, we are not getting into this calculation, but in general, the device will understand based on this calculation. The device is going to see what is the size of the network, and based on that size, it will calculate what is the how many host bits, and based on that, it will calculate the size, and based on the size, it will automatically decide what is the range, and what will be the network ID, and what will be the broadcast ID. So 0 to 255 is one network, so they become same network. That's the reason we are saying they're on the same network. But when we write the subnet mask of 255, 255, 255, 192, the device will understand that there are 26 network bits as per the bit calculation, and there are 6 host bits. So size of the network will be based on the 2 to the power of h value. So 2 to the power of h value is 2 to the power of 6, 64 is the size. So as per 64 size, group of 64 addresses become one network, which means 0 to 63 is one network. When you're writing the range, we did this in the first example, if you remember. Just keep your first example in front of you to have a more easy understanding. 64 to 127 is one network, 128 to 191 is one network, and 192 to 255 is one network, where the first addresses, whatever I wrote here, these addresses will be representing your network ID, and these addresses will be representing your broadcast ID. So which means 0 to 63 is one network, and I cannot use 0 address, I cannot use 63 because they are part of network ID. So whenever I write 192.168.1.10, if you just come down to our example, in our example we took 192. So for one device I'm writing 192.168.1.10 with a subnet mask of 255.255.255.192, which means when you add this subnet mask, so 10 coming in between this range, which means as per this subnet mask, 0 is the network ID, 63 is a broadcast ID. So the device says anything coming in between 0 to 63 belongs to my network. And whenever I say 192.168.1.100, the second device with the same subnet mask of 255.255.255.192, the device is going to understand that 100 comes in between 64 to 197, which means anything coming in between 64 to 197 is my network. Anything coming 0 to 63 is a separate network. Now device says as per this subnet mask, so these two are different networks. Based on that, what I am saying, this is how the devices understands whatever the device, networking device, routers, switch, firewalls, all the devices understand this behavior, these calculations. Only the thing is we need to have a more clear understanding how it goes, because when you get into production networks, probably you'll see these devices with this respective subnet mask, like what is the account department and what is the range. So whenever you see 10 address given, based on the 10 you have to understand, okay, it's the accounts department which is using the addresses in between 0 to 63. So that is a different network. Okay, so let me give some more clear idea on this. One more, like probably if you remember how to assign the IP address, we already know. Assigning the IP addresses, we need to go to my network places. I can go to my network places, properties, TCP IP version 4 properties, and I'm going to this device. And if you remember, we already did this in a basic IP addressing, where every device should be mandatory given the IP address. Like if I'm giving 64 IP address with a default subnet mask, so what I'm going to do is I'm going to use the default subnet mask, and if I click OK, the device accepts the IP address because as per the default subnet mask. So as per the default subnet mask, so what's the default subnet mask? Default subnet mask is 255.255.255.0. As per this subnet mask, 0 is the network ID, 255 is the broadcast ID. So we cannot use 0, we cannot use 255 because they are network ID and the broadcast IDs. But 64 is a valid IP address because so 64 is coming in between 0 to 255. It's a valid IP. So what I'm going to do is I'm going to use the same device. This time I'm going to try to change the subnet mask to 255.255.255.192. So now the question is, will it accept or it will reject? You can see it is simply rejecting the command saying that the combination of IP address and the subnet mask is invalid because all the host portions of the bits are set to 0. 0 means it's network ID. So when you say 0, it is network ID. Set to 0 means it's a network ID because if you remember, just now we did this example. The first example which we did in our previous class, as per that subnet mask, as per the subnet mask of 255.255.255.192, there are 6 host bits. As per 6 host bits, the size of the network will be 64, where 0 to 63 is one network, and you cannot use 0, you cannot use 63 because 63 is a broadcast ID. And also I cannot use 64 because 64 is a network ID for the second network range. Similar way, I cannot use 128, I cannot use 192 if I use the subnet mask of 255.255.255.192. That is the second. This is the example. The device understands all these things because the device knows all these things. So similar way, if I try 63 also, the device will not accept because according to this subnet mask, 63 is a broadcast ID for the first network. Similar way, if I try with 128 address, it will not accept because 128 is a broadcast network ID For the third network, similar way I cannot use 192 also. The same thing applies for any example. Like if you remember just now we did one more example uh, where we had taken a requirement of 12 host addresses and we got the size. What is the size? We got some range of multiple 16 addresses. Just now we did one example. So 0 to 15 is one network, 15 to 31 is one network. If I use the subnet mask of 255, 255, 255, 240, that is what I got in our second example of C class, which we did just before we started this topic. So where I cannot use 15 because 15 is a network ID for if I use that subnet mask. Let us try. I'm going to use 192.168.1.15 any C class. If I use this subnet mask, it is valid IP, but I'm not going to use that. If I use 240, the device will not accept because you can see all the IP address portions are set to 1, which means it's a broadcast ID. So we cannot use this. Even I cannot use 16. It will not accept. Even I cannot use 32 because 32 is a network ID. Even I cannot use 32 plus 16, 48. I cannot use like that. It will go on. So whatever the addresses we are writing within the range, the first and the last addresses we cannot use because they are network IDs and the broadcast IDs. So we cannot use them. Okay. So I hope these examples, all these examples will have given a more clarity on how exactly the devices understands and how we need to understand. This understanding is very important. This is the second step of subnetting, where the first step is to have a very good understanding on step-by-step calculation process, which we did in the previous class, and also we did one example today as well. And the second step, once you are a little bit comfortable with the calculation, the first step, when you practice, try to only make sure that you are comfortable with the calculations, step-by-step calculations. And once you are comfortable with the calculation, the second step, you need to try to understand how they are different networks. So I'm saying that 64, like I took one example just now, 10 and 100 are different networks. If I use this subnet mask, how they are different, how the devices understand. You just need to follow the same methodology even when you see any device. And this is very important to finding out the network ID and the broadcast IDs, especially when we do some bits, when you face certification exams where you will be tested on some subnetting questions. Okay, so I hope this is useful for you, so you have got some very good idea on this. So now we can get into some more in-depth of calculations by using A class, B class. So this concept of rewriting the range understanding is same whatever the class we use. This is the basic difference of default network and subnetwork. When we change the bits, it will totally change your range. So whenever we change the subnet mask, it changes the number of bits, it changes the number of size of the network, and also it changes the range. Everything changes to another size as per the requirement, as per the calculation.